Start Good afternoon to all. The slide is visible to all of you. Hello.
Light is visible, sir.
Okay. So now we will continue the previous lectures. And then some of the GNSS systems, how works and why, which type of signals are used for the navigation purpose and different survey systems. So we'll continue the GNSS parts. So first of all, the GNSS working principles. So basically, the satellite-based GNSS provide accurate positioning, navigations, and timing, and it includes the GPS of USA, GLONASS of Russia, Galileo of European Union, then video of China. So previously we are discussing about this all these related topics, but now how the GNSS works. So a lot of sections are there, like the satellite signal transmissions. This is the one part of this, where the GNSS satellites continuously transmit radio signals, and each signal includes some satellite position that is called as ephemeris data. So it is very important. So satellite positioning information related data is called as ephemeris data. Then precise time of transmissions with the help of atomic clock. Then system status and almanac for all satellites. So different status are recorded in the almanac. So this is the one of the part of the satellite signal transmission. Then receiver signal receptions. So a lot of equipments are there like smartphone, survey equipments, and all the navigations vehicles are there. So these are the receivers. So they receive the signal from at least four satellites. So more than four satellites informations are there. So we receive at least four satellite for our positioning accuracy. Then it measures the time delay between the transmissions and reception. So time delay between the transmissions and receptions is calculated. Then the distance is measured. So that's why the navigation system works. Then pseudo range measurement is there. So next is the time delay is multiplied by speed of light to get the pseudo range. So approximate distance to each satellite. So pseudo range is generally the range which is the from the transmission of uh, radio signal from satellite data to the receiver. So this is called as pseudo range. Then trilateration. So there are two type of survey methods are there, like triangulation method and trilateration method. So in the GPS navigation system and GPS measurement system, we use the trilateration method. Uh, Using this distance from at least four satellites, I receive the calculates. Then uh, after receiving the four satellite information, we get the 3D position, that is latitude, longitude, and altitude. And if we have three satellite data information, then we get the 2D informations, and the altitude information is missing if we have only three satellite data informations are there. Then there are two type of signals are there, that is code based signal, then carrier based signals. So these are used in the GPS system. Then different errors are there. So like ionospheric error, multipath, satellite clock, receive noise. So these are all the phases we have to go through it with the help during our satellite navigation with the help of GPS. So, working principle, the term triangulation is trigonometry and geometry. There is a process of finding coordinates and distance to a point. So this is done by calculating the length of one side of triangle with given measurement of angle. And second is the trilateration. It is the method of determining the relative position of the object with known location. So basic difference between the triangulation method and trilateration method is, in the triangulation method we measure the angle of the triangle. Based on these angles we can measure all the sides, then all the position of the uh, area. But in the trilaterations, we use the linear measurements. Uh, that's why it is more accurate. And in the GPS navigation system, we use the trilateration method, not the triangulation method. So triangulation method generally used in geodetic survey data, geodetic survey with a lot of triangles are created. So this is one of the important point, that is the satellite transmit pseudo range code. Uh, this is the important point. Then GNSS receive pick up two kind of codes, that is ephemeris data and the precise almanac data. So ephemeris is that are more precise than almanac data. Then trilateration used in GPS. So trilateration determine the location of point by measuring the distance from at least three or more satellite positions. And the working principle is the satellite position, precise time signal, and the GPS receiver on the ground. Then, with the help of the fast satellite data, you can get the somewhere on the sphere on it. Then after getting the second satellite data information, we get the circle where two spheres intersects. Then third sphere, they narrow it down to 2 points. Then four satellite information, get the accuracy and accurate positioning informations and correct the receiver clock. So we need the four satellite data information with the help of trilateration method. So generally, triangulation method is not used in the GPS system, and it is triangulation is based on the angular systems. Why not used in the GPS system? Because the GPS satellite do not measure angle from the receiver, and GPS works purely on time-based distance measurement and trilateration, not triangulation. It is very important. Then these are this is the two method, triangulation method. So all this uh, area is divided into different triangles. Then all the angles are measured. Then the all points are solved. Then after that we get the information of the different survey information. But in the trilateration, the electromagnetic distance measurement EDM is used, and the cosine rules are used to identifying the different areas with the help of linear measurements. So these are the some difference between the triangulations and trilateration. So this is the trilateration geometry of the GPS navigation and measurement. Like this uh, trilateration method, we get the accurate information about the different position. Then this is the triangulation principle. This is the process of measure the angle of chain network, and this the consist of some angle-based information system. Then what is the geodetic survey? So geodetic survey is generally used for surveying any area which is a large area. So it is converted into small triangles. So first we just survey a small, just create a overall big triangle. Then after that, inside this big triangle, then secondary triangles are created. So this is the picture. So in all India, there is a big triangles are created. Then in the second image, uh, from one triangle, the secondary triangles are created. Then tertiary triangles are created. So after getting the different survey informations, after getting that data in the tertiary triangle, then it is converted to transport to the secondary triangle. Then it is feed to the uh, uh, bigger triangles. So likewise, this type of surveys are created with the help of geodetic survey. So geodetics, generally the earth is not the flat, so it is a curvature. That's why the surface distance and geodetic distance are different. So it is calculated with the help of different mean sea level informations of the altitudes. Based on the altitude uh, normalizations, we get the height information and the area, accurate area. Then the geodetic survey extend over large area and then line connecting any 2 points on the surface of Earth at its arc for calculating their project distance on the plane or map, and the correction of the curvature is applied to the measured distance. The angle between the curved line are treated as spherical angle. A knowledge of spherical trigonometry is necessary for making measurement for geodetic survey. So geodetic survey are used like this method. So based on the triangle survey, all this geodetic survey. Then what is the pseudo range measurement? So it is only used in the GPS navigation system. So pseudo range, what is the pseudo range? Is the measurement of range or distance between the GPS receiver and navigational satellites. That is, it is the distance between GPS receiver and navigation satellite antenna. जो रिसीवर है और जीपीएस सैटेलाइट है, उसके अंदर जो डिफरेंट डिस्टेंस है, उस डिस्टेंस को सीडो रेंज मेजरमेंट कहते हैं. So how to calculate this pseudo range measurement? So P code, that is precision code, and the course acquisition code, that is CA code, are used. Generally हम P code और course acquisition codes are इस्तेमाल करते हैं measuring the pseudo code. And when pseudo random code is transmitted from the satellite, the receiver generates the exact replica of that code, and after that, transmitted code pick up by the receiver. So this is the pseudo random code. So every pseudo random code is a different and is a unique pattern. And when it is transmitted towards the receiver just receive the same pattern. So it is look like this, and the delay of time between the seeded code receiving and the signal transmitting, the time delay is calculated. So based on the time delay, we just multiply with the velocity of light, then we get the distance information. Then after that, we get the position informations of each satellite. So this is the method. This is the pseudo code. This is look like this. And each satellite has a unique pseudo random code. So different satellite maybe GNSS satellites have different unique pseudo codes, so that the receiver can analyze and differentiate the different code and different information of the locations, and it is processed and then give the unique positioning information. If these are similar, then it is confused about the data information. So that's why the codes are very unique in nature. Then, then the carrier phase measurement in GPS. Carrier phase measurement is a very precise method of measuring distance between GPS satellite and GPS receiver. So GPS generally Satellite sends signal made of two parts. That is code signal like digital pattern, and this is the carrier wave signal. That is a continuous radio wave. So दो तरह का सिग्नल जीपीएस रिसीवर ट्रांसमिट करता है. वन इज डिजिटल पैटर्न, दैट इज दिस इज द डिजिटल पैटर्न, दिस इज pseudo code, there is a digital pattern. And another is a radio wave, जो जनरली वेव होता है, मतलब माइक्रोवेव, विजिबल वेव, वेवलेंथ रिलेटेड पैटर्न जो है, दैट इज अ कंटिन्यूअस रेडियो वेव. दैट इज अ इलेक्ट्रोमैग्नेटिक वेव. Carrier wave is a electromagnetic wave, and the code signal is digital pattern wave. The code signal gives rough distance, accuracy is few meter, but carrier wave is used in carrier phase measurement to get precise distance. So कोड सिग्नल से कैरियर वेव का सिग्नल थोड़ा ज़्यादा एक्यूरेसी आता है because of the electromagnetic radiation is used, and its accuracy is millimeter to centimeter. So how this works? The receiver count the number of wavelength of the carrier wave between it and the satellites. But since the wave is continuous, it does not know how many full wave can before it started measuring. This is called inter-ambiguity problem. So some ambiguity problems are also there. So based on this, so these ambiguities are corrected with the help of some master stations and some user equipments. The special method are used for solve this and calculate the exact distance very accurately. GNSS satellites are orbiting the Earth at an altitude of 20,200 kilometers. So generally, most of the time, these questions are asked, how what is the distance in which the GNSS satellites are there. So it is 20,200 kilometer. So it is very important for short question. And then GPS receiver store orbit information for all the GPS satellite is known as almanac. It is also some of the short question. GPS receiver store orbit information. So almanac generally have orbit information. Almanac में ज़्यादातर orbit information होता है. Then each GNSS continuously broadcast the almanac and receive collect information. So generally almanac informations are generally received by the receiver for continuously use for these informations. So any deviation caused by natural atmosphere phenomena to GNSS signals such as gravity, etc. are known as ephemeris error. So sometimes due to the Earth's gravity and some atmospheric distraction or atmospheric imbalance, some signals are distorted. Due to this distorted, some data are missing. So this error is that that's why this error is created. This error is called ephemeris error. So it is a natural error. So we cannot uh, create this in the artificial way. So ephemeris is a atmospheric based error or any gravity based error based on the atmospheric conditions. Almanac is the orbital information of the GPS satellites, and the Earth's then satellite orbiting the Earth altitude of 20,200 kilometers. So these are some important points. And this is the picture of the carrier L band. L band is the radio wave band, and 1575.82 is it is a frequency. So it is a megahertz in megahertz. This is the L band. So generally we use three bands, that is L1 band, L2 band, and L5 band. So it is a L1 band. Then it is a coarse acquisition code. It is a digital code. It's a unique digital code, and its frequency is 1023. Then the carrier phase tracking. So sometimes we face problem that suppose the satellite transmit the wave in this phase, then it is a reflected wave, then it reflected to this transmitter, then this wave is diverted in different way. So this diversion of this path is called as phase shift. So there the wave cannot reflected back in the same phase, so the phase difference is there. So these phase difference are calculated and corrected for the measurement of the accuracy of the position. So here is the one of the picture is there. So this is the phase receiver, then phase different receiver, and this is the shifting of the different phase. Then most of the time we call as why four satellite informations are used for the getting the position of the latitude longitude information. जनरली थ्री सेटेलाइट इंफॉर्मेशन में भी हमको पोजीशन मिल जाता है, फिर भी हमको फोर सेटेलाइट डाटा क्यों चाहिए? जनरली क्वेश्चन भी आता है जो हाउ मेनी सेटेलाइट्स इंफॉर्मेशन आर देयर टू गेट द पोजीशन ऑफ द पर्टिकुलर एरिया. सो वी जनरली हम आंसर फोर सेटेलाइट देते हैं. So we can also get the 2D data in three satellite informations. So why we use the four satellite data? Because there are three measurement can be used to locate a point assuming the GPS satellite and receiver precisely continuously synchronized, thereby allowing the distance. But unfortunately, it is impossible to synchronize these two clock because if the three satellite informations are there, the satellite clock, it is a based on the atomic clock, so it is a very high accuracy, but in the receiver clock its accuracy is very less. So when the satellite data is moving the very fast velocity, that is 13,000, more than 13,000 kilometer per hour, so due to the speed, high speed of the satellite data, and the receiver is in low accuracy of the atomic clock, so the distraction is there, then distortions are there, and some information are not exactly um, received. So that's why for the accuracy we get the another satellite information, that is uh, 3 to 4 satellite. The shift is 3 to 4 satellite. These are the some issues, but ideally we can get this, but practically it is not possible. So this is the three satellite information, the position of determined. So we have to get the data by the help of another four satellite information to get the accurate of the position of that location. So this is the atomic clock timing of the satellite. Then this is the receiver timing. So the time difference is the dt. Then we d2, we measure the dt by the receiver. Then we calculate the distance. Then multiply with the velocity of light. Then we get the distance. Then what is the basic calculations? So these are some calculations are there. The calculation of the receiver use four equation in the four unknown areas, that is x, y, z, and tc, where the x, y are the receiver coordinates, and tc is the time correction of the GPS receiver clock. So these are the unknown coordinates x, y, z, x, y, z, and tc. Then distance 1 is calculated with this formula. Then distance 2 is calculated, distance 3, distance 4. All these distances are calculated, where c is speed of light, and t1, t2, t3, t4 are times the GPS satellites respectively, and tr1, tr2, tr3, tr4 are the times that signal from GPS satellites 1, 2, 3, 4 respectively, and X1, Y1, Z1 are the coordinate of GPS satellites. So this is the method. Based on this method, the GPS receiver calculate this distance with the help of all these signals. Then some example of the different application in the GPS navigation systems are there. Surveying and mapping. So ज्यादातर surveying mapping and nowadays lot of GPS use are there, like in the GPS in the mobile or in DGPS survey. So geodetic control survey, GIS mapping, structural deformation survey, coastal engineering survey, remote sensing application control survey, geophysics, geology, archaeological survey. So all these surveying mappings are useful for the with the help of the GPS satellite. Then navigations like automobiles, aircraft, maritime, then pedestrian, all these navigation related techniques are used with the help of this GPS. Then tracking, delivering system, precise farming, then geodynamics, that is global and continental plate movements and deformation analysis. So generally, Survey of India taking these responsibilities for the plate movements and deformation analysis with the help of GPS survey, and this is the part of the geodynamics. And then engineering surveys like monitoring movements, and ground subsidence and dam deformations. These are also used. Then mining, surveying of preparation of mine plans, then survey for the land for mines and area of the mining area. So these are the applications. Then photogrammetry and remote sensing also used. Then science and research, topographic studies of predictable water vapor, ionospheric monitoring, earthquake predictions, weather forecasting. So all these atmospheric related informations are getting with the help of this GPS satellite technology. Then space application like positioning, navigation of other space vehicles, which is also useful very much. Then location-based service, that is emergency response, medical advertising, all these. Then military applications, low-level navigations, resonance, route navigations. A lot of applications are there with the help of this GPS system. Then uh, L1, L2, L5. So previously we just discussed there are three frequency bands in which the GPS satellite transmits these signals to the receiver. That is L1. So most of the time in the short questions, they are asking what is L1 frequency, what is L2 frequency, then what is L5 frequency. So this is generally the L1 frequency is the 1575.42 megahertz, then L2 is 1227.6 megahertz. So L2 is the low frequency. That means it is a high. That means it is a high wavelength. So more frequency means low wavelength. Then less frequency means high wavelength. It is inversely proportional. So frequency is inversely proportional to the wavelength. And then L1 carrying the generally L1 is the CA code that is used for the civilian. Then P code, that is the precision code generally used for the military purpose, because in the military purpose the precision code is very highly accurate and it is not shared uh, by the government to the civilian. And the L2 primarily carrying the precision code. Then L5 it is 1176.45. That is also a lowest wavelength, but frequency. So the wavelength is it is high wavelength and low frequency. And it is a newer frequency, that is L5, part of the GPS modernization effort and designed for the safety critical application like aviations. So generally L5 is recently used for the aviation purpose. So these are the different GPS GNSS system, that is GPS, GLONASS, Galileo, Video, RNSS, that is Indian satellite, and then QZSS and then L-band. So all these satellite system are using this type of bands, that is L1, L5, then V2A, ESA. So it's a lower band, then the upper band. So this is the features of the GNSS frequency band. Then this is the four GNSS constellations. So in GPS, generally 24 satellites are there. So total 24 satellites are there, and there are six orbital planes are there. In the six orbit, 24 satellites are moving uh, around the Earth. So in one orbit, there are four satellites are there. So at least in the one orbit, we get four satellites. And in the Galileo, there is the three orbital plane and 27 satellites are there. In the GLONASS also three orbital plane and 21 satellites are there. And Video, there are six orbital plane and 36 satellites are there. And the height altitude is for the GPS is 20,200 kilometer, and for Galileo it is 23,616 kilometer. Then GLONASS it is 1910 kilometer, 19,100 kilometer. Then for Video it is 38,300 kilometer, and some part is 21,500 kilometer. So these are the altitude of this GPS system, and different orbital uh, planes are there. So most of the time, some sort of questions are asked: how many orbital planes, and each orbital plane, how many satellites are there. So this is the total channel required in the ideal reception of condition for the GNSS receiver. The GPS, there is a 24 satellite. Satellite over the measurement point is 10, and the number of frequency bands are four. So there are four frequencies are there: L1, L2, and L5, and uh, all other some E6 bands are there. So four frequency related informations are there. Then for GLONASS it is 21, for Galileo it is 27, and Video for it is 30 satellites. So these are the, but nowadays the satellite numbers are changes. Some more satellites are launched, and some satellites are used for the backup purpose, and it is continuously updating this navigation satellites for the high accuracies, and some backup purpose also. There are three satellites are launched in the GPS. So there are 27 satellites, 24 are operational, and three are backup purpose. So in this, there are two type of GPS positioning service. That is standard positioning service and there's precise positioning service. So what is standard positioning service? In the standard positioning service, this is available for civilian user worldwide. So it is use the L1 frequency, that is 1575 megahertz, and it provides moderate accuracy, generally 5 to 10 meter. So we use this in the mobile and other small GPS devices. So it is a standard positioning service system, and no encryption, freely accessible, and suitable for general application like navigation, surveying, and mapping. So here we use this in the mobile with, without any payment or any encryptions are there. Any there is no encryptions is there. Then precise positioning service, that is restricted to authorized user, mainly military use. So there is encryption is there. It is not freely accessible, and it use both the L1 and L2 frequency, that is 1575 and 1227 megahertz frequencies. But in the case of standard positioning, only L1 is used. But for the PPS system, L1 and L2 are used. It offers high accuracy and encrypted signal for anti-spoofing and security, generally used for defense and missile guidance. Precision operations are there. So some of the GPS measurement techniques are there, like code-based pseudo-range measurement. This is the measurement, the time delay between the satellite signal and transmission to receive reception with the PRN code. Then carrier phase measurement. Then differential GPS, that is DGPS. We will discuss later about the detail of the DGPS. Then real-time kinematic RTK positioning. Then post-processing kinematic PPK positioning. Then static GPS surveying. So these are all different type of measurement techniques are used with the help of GPS for lane survey and other survey. Then after that, we get the all the GPS data with the help of different signals. So some errors are there. A lot of errors are there from the different stages of the Earth surfaces. First is the satellite clock error. So most of the time, GPS satellite have atomic clock, but some some timing error can be cause positioning inaccuracies. So if a 10 nanosecond error can causes a 3 meter positioning error. So it's a very precise timing can be used, but if any small error can cause the large error in the with the in the satellite clock. So it is very important to take the information of the satellite clock, which cannot be uh, it can to avoid the error. Then orbital errors, that ephemeris errors, that is inaccuracy in the satellite's reported positions, or can lead to the several meter error in the user position. Then ionospheric delay due to the some upper atmospheric issues or imbalance slow down the GPS signals, highly variable, especially during solar storm and near the equator. It delays the ionospheric delay. Then tropospheric delay, the lower atmosphere also delays some signals due to some humidity, temperatures. Unlike ionosphere, this delay is not frequency dependent. Then multi-path error, some signal bounce off nearby object, buildings, water, trees, hilly terrains before reaching the receiver. So this is also one of the error. That is a multi-path error. Then receiver noise, some internal electronic noise in the GPS receiver is also cause some noise. Then satellite geometry also give some uh, errors, because if the if the geometry of the satellites are in linear way or in a particular one-sided one direction, then we get the error. So that's why we just uh, take the information of the all the satellites from different directions. So it is advisable to get the information of the satellite data from the different directions, so not in the linear ways. An antenna phase center variation, the antenna receives signal at slightly different points. Human operation error also there. So due to some surveying, wrong way of surveying, or uh, different technicalities error are there in the human perspectives. So these are the errors. Then typical GPS accuracy impact summary, and that is error source. So in the satellite clock error, we approximate the impact that it get the error of 1 to 5 meters. Then ephemeris errors in the atmospheric area, that is 2 to 5 meter error. Then ionospheric delays, that is 5 to 15 meter error. Then tropospheric delays, that is 0.5 to 2 meter error in the accuracy of the location. Then multipath error, it is more, that is 1.5 to 10 meter. Then receiver noise is 0.1 to 1 meter. And geometry related error in the GPS system, that depends on the value. So how the geometry is associated with the different angles. So these are the error, and this the error positions of the different error. So these are the three phases generally we arise the errors. That is individual level, that is the from the biased level, then receiver clock, or then the multiplier. So this is the lower level error for from the receiver. Then local level from the tropospheric errors, then ionospheric error. So atmospheric errors are in the local level. Then the global level, it is because it's, why it is local level, because a different area in the different country, it is not getting the error of same satellites, because some ionospheric and tropospheric error are not found in different locations. Particular some location we get the ionospheric and tropospheric error, but not it is not globally calculated as a error. Then globally error is, that is the clock error. If the clock is some missing the data, or the accuracy of the clock is less, then it give the globally error data to all the receiver. Then orbit, so if the orbit is shifted to its different positions, then also it give the globally erroneous data to all the receivers, the all the stations. And then biased and some different satellite tracking, or any path error, or any geometry error. These are also create the global level error. So we just see that there is the individual level error, which is in the receiver level, then local level error in the atmosphere, then global level error based on the satellite. So these are the three type of errors are found in the GPS system. Then we will discuss question, some short questions based on these slides. So the first question is, how many minimum satellites are operational in the constellation of GPS? So it is a 24.
Yes, sir.
Then
24, sir.
yes. Then Galileo system for navigation is operated by Galileo is the European.
Europe.
Then the GPS operated by India is Compass, GLONASS, Galileo, that is Navig. It is also called as the Gavan. Then mathematical principle involved in GPS. So which mathematical principle is involved? It is not the graphical resection, analytical resection, trilateration, triangulation. So it is a trilateration
Trailer. Yes.
principles. Then the service offered by GPS, generally positioning, navigation, and timing. So these are three important services are given by the GPS, that is positioning, navigation, and timing. Not only one. Then the satellite placed in the constellation of GPS arranged into which orbital are surrounded to Earth. The satellite placed in the constellation of GPS arranged into how many orbital surrounded to Earth? So recently we just discussed there are six orbitals. In six orbit, each orbit is four satellites. So 6 into 4, 24 satellites are there in GPS, which is for US. And the epoch in GPS is coded sequence of the epoch is coded sequence of time of arrival. So it is epoch in GPS very short period observations. So it is the time of arrival of the signal is called the epoch. It's a very short time, and which is very very small time is there. That's why it is called as epoch. So the answer is also it is described in the lower part. So based on which receiver of the GPS indicates how far the satellite located is. It is the answer is the time difference. Only the time difference the receiver can calculate, and this based on this time difference is calculate the distance, and based on this distance is calculate the location. So basically, GPS receiver uses the data based on the time difference. Then a device altitude can be measured using how many satellites. So suppose a device is there for
Fourth cell.
altitude information, that is four.
Fourth cell.
Four. So for 2D that is third, and for the 4D that is fourth. How many satellites are required to measure 2D position, that is longitude and latitude, that is it is three.
Three.
How many methods used for the surveyor in the measurement of GPS? Generally for the measurement of the GPS, static GPS baseline, real-time kinematic observation, and continuous operating reference stations. Three methods are used. So today we have this slides for the GPS system. We will discuss some um, basic of DGPS in next class, and the basic of GIS, how this GIS are helpful for different applications. So now I just mm, give you some basic practical about, suppose we have some GPS data in the Excel format. So how to convert this Excel format GPS data into the shape file or GIS format? I just show one example with the help of this practical. So for this we just use RGS software. So I have some Excel data. This is my Excel. So based on this information of the Excel data, we can get the GIS format shapefile creation. Basically, we use latitude as a y-axis and longitude is a x-axis. First, we have to convert it into the CSV format, save it.
Start in.
So we have to go to the file, then add data, then add XY data, then we have to browse to the folder, then D, and this is a honey training data. These are the location of the honey culture training locations in the Odisha. So after that, we get the X field is longitude. No, it is yes, X field is longitude. Y field is latitude. Is clearly mentioned. Then there is no height information in our Excel. Then we have to edit these projections to geographic coordinate system. So we get the geographic coordinate system in WGS 1984. Then we get the data. So we get this data. So it is not presently is not in shapefile format. We have to export it. Then it creates a shapefile. Before that, it is not created the shapefile to get the location of all these informations. Likewise, you can get all this information from the field data. Then we just input into the Excel. Then it is converted to the GPS format. So just I go through this. So this is the degree minute second. We can also search it in the Google Earth software. Just click on the I identified tool, then click on any of the point, then get the information of the location, then copy this location, then go to the Google Earth software, then paste it. It shows the exact location which is chosen by us. So this is the site, this is the village. So where the honey culture meeting was held. So exact location is there. So this type of you can use for different applications or different data creations. These are some of the legends. Okay, then we'll discuss the other topic in the next class. and some practical also we can uh, discuss, and we can I can give to some basic practical in the tomorrow or day after tomorrow class. Okay, then
Thank you, sir. Thank you.
Okay, sir. Thank you.